All right, we're going to get started with a nice little easy exercise that's going to illustrate how you can define your own data structure, kind of like what you do when you define classes for those of you who already dabbed a little bit with an object-oriented programming language. But we are not going to exactly go into that level of complexity. We're just going to define structures, give a name to a new data type, and then write a few methods that are using that structure. Okay, so it's really a direct illustration to the kind of stuff you've seen in the lectures and reading assignment. So in this example, this specific example, I'm going to go back to the code here. We are going to need to define three files, to create three files. A01.h is going to be our header, going to contain the data structure definition, any macro like pound define statements, that we might need. It's going to contain also, sorry about that, it's going to contain also the header for our functions, the prototype for our functions. And then we are going to have A01.c, which is going to contain the implementation of said functions, and main.c, which is going to allow us to implement a little bit of a sort of interactive interface. It's a big name for what it is. We're just going to ask the user, hey, do you want to enter data for some of the records that we have? And then we're going to redisplay that data back to the user. Okay, but all the interaction between the user and the testing of our function is going to take place in main.c. So let's get started. Let's go and say that we need A01.h, A01.c, and main.c. All right, there we go. So now that we have those files in our editor, we're going to put stuff inside of them, of course. So let's start with A01.h. So first thing, pragma once. Okay, I don't want to risk multiple inclusion. And then I need to define my structure. So the structure that we are going to define in this exercise is an employee record, supposed to contain some information about employees working in a company. Okay, it's going to be very minimal. We don't need it to be long and tedious to enter to illustrate the concept that we need. So we are just going to have a social security number and the full name of the employee as a string. All right, and we are going to do this in several versions. Okay, this exercise is the first version. In the first version, we're going to pretty much hard code everything. The size of the string representing the name is going to be hard coded. Like the number of records that we are manipulating, employee records we are manipulating, is going to be also fixed. Okay, and then progressively we're going to release those constraints, and we are going to do more dynamical memory allocation, both for the table that contain all of our employee records and for the strings that represent the name of the employee record. Okay, but we're going to do that progressively. So the first step is, how do we define a struct in the C language? So struct, I'm going to call it struct employee record, and there are so many different convention for naming here that you can apply. When you work for a company, they tell you what kind of convention they want. Here I'm going to just use a random one. Okay, I'm going to write this in this case employee underscore record. Okay, all lowercase, etc. This is going to be the name of my structure. So inside that structure, I'm going to have, so we talked about having two things. We talked about having a social security number. So social security number, that's what, like 7, 8, 9 digits, something like that. So you are going to need a long if you want to store it as a number. So that's what we're going to do. We could store it as a string. There would be maybe some verification to do there to make sure that it's only digits inside of it. But in our case, we're going to use a long that will be good enough for our little example. So a long SSN, social security number, okay? And then a string that I'm going to call name. The name of the field is going to be name. So this is the full name of the employee. And I'm going to say that, well, you know what? The full name will not exceed 40 characters, which is completely arbitrary, okay? You can imagine somebody who would have a very long name that would exceed 40 characters. So this is always bad when you have things like that, like hard restriction. So one way to work around these is to put an arbitrary large number and then to resize the buffer. That's what we are going to do in the next exercise. We have done that already in other videos that we are dealing with strings, but for now, I'm going to go with the simplest possible implementation. However, even in the simplest possible implementation, this is really not good. Okay, putting that number 40 here, that's really not a good way to do it. I just want to underline that. Okay, we would be better off having a constant. We would be better off having any sort of pound define. For example, here, pound define a precompiler directive that would say max length employee name, and then set that to 40, okay? The idea being that if I need to change that anywhere else in my code, well, I can use that macro that I defined here, okay? This is pretty much a macro, and I can use that instead of having to write 40. And when I want to change it, well, I should be able to change that just by changing the number here. So if I decide to go with an arbitrary large number, there we go. This is one place in the code where I would have to make that change, okay? And that's it for defining a structure. The problem with that is that every time I want to declare a variable, so I'm not going to declare a variable here, but I'm just going to type one declaration to show you. Every time I want to declare a variable of type struct employee record, this is what I have to write as the data type. Okay, so for example, here's an array of 5 employee record. Okay, so this name here, a little long, okay, the struct keyword, repeating it all the time. So most of the time, we try to get away with not having to repeat all of this. We want a type name, for example, like employee record, which is what is asked of you in the exercise, okay? How do I associate that type name to a struct employee record? Type def. So type def employee record struct employee record. All right. So the idea here is that you are redefining a new type name, the name of a new data type. Sorry, and you are going to make it so that we can use that alias pretty much every time we want to say struct employee record, and that's going to make things a little easier for us. So now that we have this type def, we are going to be able to go to, for example, our main.c, and we're going to be able to use that alias, except that, of course, I messed that up. The alias is in this order. All right. So you put the name of the data type that already exists here, struct employee record, followed by the alias that you are trying to define with type def. So that's it for now for A01.h. As a matter of fact, I don't think we're going to have to add a lot of stuff to A01 period. Let me see. We have no, we are pretty much done with A01.h except the prototype for the function, but we're going to come onto those one at a time after. So like right now, I'm going to leave A01.h alone. I'm going to go to A01.c, and the first thing I'm going to do is I'm going to include A01.h. So pound include A01.h. So I get the definition of the length of an employee record name, the struct definition, and the type def definition included. So now I can write my function here using those definition, of course. What am I going to use inside? I'm going to use probably stdio. I'm going to include stdio.h because I'm going to do some scanf and printf. I'm going to include stdlib.h to have all the command definition. And I'm going to include also, just in case I need to manipulate string.h, okay, which is likely in this kind of exercise. And that's it for the inclusion that I need in A01.c. And then main.c, I'm just putting the minimum amount of code in each of the files, okay? Main.c is going to do pound include, there we go, so where's F, so type in the right window, A01.h as well, so that I can use all of the data structure definition, and also as soon as I put the function prototype, that will allow me to call those functions. And then int main, and I'm going to here. So what we want to do is we want to read, I don't know, let's say 5 employee records from the user, okay, and store them in a table, in an array. Then I want to display all employee records, ask the user which employee record to display. Okay, so these are pretty much the things that are required in the exercise. So we're going to fill in those blanks progressively as well. Let's start by declaring actually our variable. So I want to have an array of employee record. Two ways I could declare this: struct with a correct spelling, that helps. Employee record, and then I could say, okay, I'm going to call this my data, and I'm going to say this is an array of 5 employee record. Here's the first possible way to define our array of 5 employee record. Second way to define our array of 5 employee record, well, we have this alias, right? So might as well use it. So this would be also a way to define our employee record. So we are going to try and compile both, okay? Let me go here, GCC, so we are going to have A01.c, which contains pretty much nothing right now, and then main.c. No typo, no error whatsoever. If I run it, of course, it's not going to do anything because I'm just declaring a variable. And then I'm going to test also using the alias here. So again, GCC, perfect, that compiles in both cases. Okay, so we have a way to define an array of 5 employee records, and we can do the same trick here that we did before. So number of employee records, use that as a pound defined constant, or we could use a constant variable or even just a variable. Okay, define number of employee record to be 5. Okay, all right. So now that we have this out of the way, and I'm going to modify this just in case we increment it later. Okay, now that we have this basic stuff out of the way, let's go back to our A01.h file. So inside A01.h, I mentioned earlier that the one thing that's missing right now is the header for all of our functions. So we're going to get rid of all the headers in one shot. Okay, so with looking at the instruction, we know that we have 3 functions that we need to write. One named scan data is going to pretty much take as parameter, this array where we want to store our data, and a number. And that number is going to say how many employee records we want to store in that array. And for each employee record in the array, it's going to ask the user, please give me the name of this employee, please give me the social security of this employee. So to make things easier, we're going to display a message such as enter the information for employee number 0. It's going to be the first record in the array. And we're going to ask prompt for the SSN, prompt for the full name of the employee. Okay, so that's scan data. The way it's going to look is it's not returning anything. It's named scan data, and it's going to take an employee record array named data as parameter and a size, and that's it. Okay. Once we are done with this method, we're going to be able to fill up the array that we have defined in the main method. Okay, we're going to be able to call scan data, and we are going to pass to it Mydata, comma, number of employee records. All right. Of course, I'm going to add a little prompt here and stuff like that, okay? But for now, this is the main step. The main step is going to be calling this scan data function right here from the main. So this is how we want to use it. And this is how it's going to be defined. So this is a prototype, which means I can take this prototype, I can cut and paste it here in A01.c, remove that semicolon, put a block of code here, and instead this is what I'm going to, this is where I'm going to put the code actually for this function. So that's the first function. Let's compile just to get rid of typos and whatnot. Okay, no typos so far, so good. And then what are the 2 other functions we need to write? Well, once we are done filling up our array with data, The second function is going to allow us to display everything that is in this kind of array, okay, an array of employee record. So that is going to be also a void function, and it's going to be called display data, okay? And it's going to take, again, an employee record array that I'm going to call data, why not? And it's going to take the size of that array. So same thing here, display data. I can go to a01.c. I can use the prototype and then put an empty body for now, but this is where I'm going to put my code. And in main.c, I would here call display data, and I would say I want you to display all the information about all the employees inside the array Mydata. And how many of those employees do I have? Well, that's something that we have as a constant here. So number of employee records is what I'm going to use as second argument. Okay? All right, so that's 2 out of 3. The third one, as you guessed, is going to allow us to display one specific employee record. So we are going to ask the user which employee record to display. This is going to be done here using a scanf, okay? So we're going to do it in the main. We don't need a function to do that. But then, when we have the number of the employee that we want to display, for example, let's call it that employee number, okay, and by default we're going to say this is 0. Once we have written the code here to ask the user to provide a new employee number, read it from the user, put it in the variable employee number, then we should be able to call our third function, which is going to only display out of this entire array, it's going to only display one employee record, the one that we specified with this number. And there's a lot that we could do there. We could actually check, to make sure that we don't have, for example, we don't ask to display employee number -1 because -1 is not a correct index in an array, or if we provide an index that is bigger than the size, stuff like that, right? There's a lot of verification we could do there. We're going to start with a simple version that's not safe, and then time permit, we're going to add some more verification to it, okay? But for now, let's go back to a01.h. The prototype for that third function is going to be also void. None of those functions are returning anything. Display data at, and I'm going to be able to provide an index. Okay. So again, it's going to look like very similar. It's going to be employee record data. That's my first parameter. And then int, instead of the size, I'm just going to pass an index. Okay, this is going to be the index of the employee record that I want to display in that array. Okay, with those three functions, we have a very minimalist program that's still illustrating, how to define a data structure, how to work with it, how to use an array of elements that are of type that data structure, and stuff like that. So it's a good starting point. But like I said at the beginning of the video, we are going to progressively add more to this. So now that I have this third function prototype here, I'm going to cut and paste this again, once more. And I'm going to come here and I'm going to say, here is where I'm going to type the code for this function. So display data at with an employee record and an index. All right, so we have our work cut out for us. Okay, these are the three functions we need to implement. We have their prototypes in the header file, like we should. We have a definition of the max length for an employee name. We're going to see how we use that, actually. And then we have like our structure and our type def, and we are ready in the main.c to use those functions. So the last one, I haven't typed that yet. The last one would be display data at my data, and then employee number. Okay. And for now, it's going to display always the first employee number, but then I can add here, a scanf, a printf to tell the user, enter the employee number, read it from the user, and be done with that. Okay. As a matter of fact, why not do it right now? Printf, which employee do you want to display? All right, and then scanf. scanf, I'm going to read an int, and I'm going to store that inside the variable employee number. All right. And again, this is where I could also do some verification. You know, are you in the right range, etc. I'll leave those as an exercise. The basic version is here, and adding this kind of stuff, like adding a little loop here that's going to keep asking for a number and reading that number, and keep doing so until the number is between 0 and number of employee record minus 1. That's something that we have already done in the past, so you should be able to add that by yourself as an exercise. But if you bump into a problem, you know where to find us. Okay, the TAs and myself, come to office hour, ask questions, post on Piazza, forums, whatever we're using this semester, and you'll get help to complete that. Okay. So we have a good outline here of our main.c. We have a good outline for the implementation of the function. It's completely empty, yeah, but still it should compile, and it does not. So let's check what's happening. Implicit declaration of function printf, that's a pound include that's missing. So let's go back here, and we are going to do in our main pound include stdio.h. Okay, that should help. And I might have to do std and stuff like that too. Let's recompile. There we go. That's just what was missing here for our printf, and probably scanf as well. So it compiles. If I run it, of course, it doesn't do much. It doesn't do anything for the scanning, doesn't do anything for the displaying, then tell me which employee you want to display. I say free, and it doesn't do anything because it calls the function with a free, and the function is empty. So now we're going to implement the body of our free functions. So these are going to be relatively easy. Again, that's the goal of this exercise, ease you into using structures, right? Let's look at the first one. Scan data, employee record data, etc. Okay, so we want to repeat an action here. Okay, we want to repeat prompting the user to enter the data for one employee, and we want to repeat it a certain number of times, and it's given to us by the argument, the parameter, sorry, size. So that sounds like a loop, right? So we are going to get started with a loop, a counter control loop. We control how many times it's going to iterate based on a counter value. Okay, that counter is going to be implemented with a variable I, and we're going to set the number of iteration with I moving from 0 to size -1. So that's why I use lesser than here instead of lesser equal. And then I'm going to increment I again at the end of every loop. And there we go. I have the body of my loop ready to write. So what do I want to do inside every iteration? Well, I want to say things such as printf, tabulation to make it look pretty, information about employee number, and I'm going to display here a number. SMD, go to the next line. Okay, so what is going to be that number is going to be I. So I'm going to start by saying information about employee 0, then information about employee 1, information about employee 2, and so on and so forth. Then I want on the next line, and I'm going to indent further, I want to input the full name for this employee. There we go. So these are prompts, okay? Just telling the user what I want them to enter. And I'm going to say full name is equal to, and let them type what the full name needs to be. I'm going to use a scanf, okay? I'm going to use a scanf, and I'm going to say person S. I want to read a string, and I want to read it inside of data index I. Is that data? Yes, it's data. I was thinking my data. And how do I specify? So this allows me to specify one of the employee record inside the array named data. And once I'm looking at one employee record, the one at index I, for example, how do I specify that I want to read the string into the field named name? Okay, well, dot name. Dot notation comes in handy here. What else? I have the SSN, so printf, tab, social security number equal, and I'm going to similarly scanf So the code is going to be different here. I'm going to come back to that. It's still the employee record at index I that we're trying to fill, and this time it's a field SSN that we're trying to fill up with the data that the user is providing. What is the code for long? %LD. This is the format specifier for scanf to allow us to read a long value, and that's pretty much it. Okay, with this we are going to enter the data in our employee record. Now take a minute to pause this video and tell me what's wrong with this. Okay, it should compile. So first I'm going to make sure that it compiles so that we don't have any syntax error. But even if it compiles and if it runs, you are going to look at this and you're going to tell me what is potentially wrong with this. Little hint, it has to do with security. Okay, so pause the video. I'm going to assume you're done, or you didn't pause if you didn't feel like it. That's all right. And then we're going to discuss a little bit here what's happening. %S is dangerous. Okay, %S is dangerous because it allows me to enter a string of any size. Remember that? So what we have here is, on the one hand, we are allowing to enter a string of any size. On the other hand, we are saying that, well, we are going to store that string in something that is a fixed size array of char. Okay, so if I have max length employee name, let's say that max length employee name is equal to something easier, right? 40. So this is equal to 40. What does that mean? That means that inside the name, I can store 39 characters that actually represent the name, and I'm going to use the 40th character to store the end of string marker, \character \0. So be wary of that, okay? Be mindful of that kind of stuff. Here, we're just writing a very simple version to get us started. But if you're curious, check out how you could make this a little bit more secure and come to Office Hours to get help on that as well. But I'll leave it as an exercise because that's not the focus of this video. Here, the focus is more on how to use the fields, how to put our structures in an array, stuff like that. All right, so we have scan data here that is it called from the main actually yet? Scan data, number of employee, yes. So it should have actually asked us for some information here. So I'm going to make sure that all my files are saved because I don't think they were all saved. Recompile, and yes, there we go. So we had here a file that was not saved. Which one is it? A01.c. And there was a little error here. I probably forgot. Yes, I did forget the ampersand. So I need the ampersand here. I don't need the ampersand here. Why? Because this is already a pointer. Okay. But this is just a long. So I need to pass the address of a long to scanf. We already covered that when we learned to use scanf. We covered it again when we learned more information about pointers. But if it's still, you're not sure, you don't understand the difference between line 11 here, why we don't have the ampersand and why we have the ampersand, we need the ampersand on line 13, don't hesitate again, post on forums, come to Office Hours. Okay, I will re-explain that for you. But right now, this is what I need to do to fix this problem. So let me go back again and compile. So now I'm compiling all the files, so we should see a difference when we are trying to run it. There we go. Information about employee 0. What is the full name? The full name is John Smith. I know, very original. And then the SSN, and it skips the SSN. So we've seen that already, right? When you have multiple scanf, one after the other, you have to do what? You have to get rid of that enter. Like when I type John Smith, enter, what I put in my buffer, I put John Smith, and the character that corresponds to a return, a new line, which is \n, okay? And that character \n is not read when we read the string, it's read when we do the second scanf and we try to read the SSN. So this is going to happen, we already saw that in the previous video, so we just need to clear the buffer, pretty much read that \n to get rid of it, okay? So we are going to do just that. We've seen in previous videos different way to work around this, okay? So what we're going to try to do here, we're going to try to do something different. So instead of, for example, reading a single character, to kind of consume that \n. So there are different things that we could do here to resolve that problem. One of the first things that we have seen in previous video is, well, we have that extra \n in the input buffer. We are going to just do a get char, read it, so that by the time we do the next scanf, it's not there anymore, and the scanf doesn't return with nothing, pretty much, thinking that we hit enter without providing a SSN. So that would be one way to do it. We can use fgets, but we can kill two stones with one bird. Okay, we can actually solve our little security conundrum that we just talked about, and we can at the same time solve that little problem here that we have with the scanf working like this. How do we do this? Use a better way to read a string. Namely, instead of using scanf to read a string, use fgets. So fgets is going to take the name of where we want to write our data that we just read. Okay, so the name of the string variable. It's going to take a value that tells us how many characters maximum we're going to read. So this is where it becomes more secure. Okay, I can take this constant here and I can put it there. So the constant is defined in a01.h, but since a01.h is included in a01.c, I have access to it. And then I can finally specify where I want to read. So fgets is meant to read also data from files and whatnot. In this case, we don't want to read from a file, we want to read from the keyboard. Anything that's entered in the keyboard is called the standard input of your program. Okay, so by default, when your program starts, it's connected pretty much to the console's keyboard, and anything you type is going to go into stdin. So stdin is what we specify here to be able to actually enter the data, right? So we have data index I.name, we have the max length here that we got from the other file, and we should be good to go. So let's save this. Let's stop execution of this version of the program. Let's actually recompile, run again. Full name, again, let's be original, John Smith. And then now, what happens is that we read at maximum. It's 40, I think, 40 characters, so John Smith is not a problem at all. And then we consume that \n at the end, so that the next scanf is going to allow us to enter here a social security number. Okay? And I think I press enter twice. We're going to double check here. We should be able to continue entering data like this. So let's rerun it just in case I messed up here. Otherwise, we have another problem with the next scanf, which we can solve very similarly. Okay. So first name, last name, hit enter only 1, 3, 4, 5, 6. And then, yes, we have the same problem here because I do 1, 2, 3, 4, 5, 6, enter. This scanf only reads 1, 2, 3, 4, 5, 6, and then ignores the enter. So we are going to fix that next. So for this version, we don't have a security issue. Okay, so we can simply use the old trick that we saw in the previous video. We can do a get char, not even store the result of get char in any variable. Okay, just use a get char to read that \n, and we should be fine. So save this, go back here, interrupt this, compile again, and we're going to rerun it. So there we go, John Smith, SSN 123, information about employee number 1. So this time the transition worked. Joseph Smith, 456, and it keeps on going like that. We're going to go through the whole Smith family. Rebecca Smith, 789, and then Joseph, I'm sure you spell it, Smith, employee number 3, 1, 2, 3, 4, 5, 6, and then the last one, Rick Smith. There we go. And now we are done with the scan. We need to make sure that everything went right, okay? That all the data was correctly saved, that we didn't butcher the reading of the string or the reading of the SSN. So that's going to be what we verify by using the next function, which is going to be that function that displays all the employees. But for now, the main just tells us, which employee do you want to display? I say employee number 3, but of course the code is not there yet, so we don't have anything happening interesting yet. But we are going to fix that. We are going to write now the display data and display data at functions. So let's jump right in. And these are going to be like very, very straightforward, more straightforward than what we had to deal with here with the scanf, and stuff like that. So let's start with display data. Okay, display data is going to be very easy because we are going to rely on the fact that we assume we already have display data at return somewhere. So we need to display the information about a specific employee. Okay, and we need to repeat that for every employee in the parameter data. So we need a loop for int I equals 0. It's going to be the same format than before. I lesser than size, I plus plus. And what do I need to do here inside this array? Display data at. And I'm going to pass my employee record array. And I'm going to say I want to display this employee. Employee number 0, then employee number 1, then employee number 2. So it's really easy to write, but it assumes that this function is also implemented. So we need to implement this function now. So how are we going to display the information for one employee? Printf. Okay, there's going to be a printf somewhere. And we're going to say employee number person D. So we're going to specify that in a second. And we're going to put everything on the same line. I'm going to say the name is equal to %s. The SSN is equal to %ld. And then go to the next slide. And the data for each of those placeholder is a format specifier string. I'm going to have employee number D. So this is the index that you gave me. I'm going to assume the index is valid. Okay. Then the name is going to be, so I'm going to go into data index, whatever index you specified. Okay. And I'm going to fetch inside this element the name of the employee. And then similarly, that's going to be data index dot ssn. That's going to give me the social security number. And I should be all set. Okay, it's just a printf statement. So let's save. Let's get rid of any typos and stuff like that. So we compile. Let's run it to try it. So I'm going to go a little easier here on the name so that I don't have to hesitate every time try to find something non-original. So the first employee name is going to be 1. SSN 1. The second employee is 2, SSN 2, then 3, you've got the ID here, then 4, and it's going to be easy to debug, right? When we display the name of the employee, if they are not in the right order, we're going to see that right away. So employee 0, name 1, SSN 1, 2, 2, 3, 3, 4, 4, 5, 5. Perfect, this is working except for what? Why do we go to the next line like that? We go to the next line like that because we display a long string. Okay, so yeah, this is not really looking like super nice here, but at least it's correct, it's working. So do we want to display a specific employee? Yes, why not? But this time it should be working. So I'm going to say I want to display the fourth employee, ID number 3, and it's going to display employee number 3, name equal 4, SSN equal 4. Okay. So, all right, this is actually pretty much what we needed for this first version of the program. So we are going to wrap up this video here. We have our, like I said, first version, and what characterizes it here is that we have a fixed number of employee record. Next version, we are going to work on that, make it a little bit more dynamic. All right, as usual, thank you for your attention, and I'll see you in the next video.